All right, today we're diving into a step that is absolutely crucial in machine learning, but sometimes gets overlooked. It's the one thing that takes a model from just being a cool experiment and turns it into something actually useful. We are talking about model serialization.
So, picture this. You've done it. You spent hours, maybe days, tuning and training this perfect model. The accuracy's amazing, you're feeling great about it, but then you have that moment of, okay, now what? How do you get this thing out of your code and into the hands of users? Because here's the reality. Right now, that incredible model you built, it's got a huge problem. It's brilliant, yeah, but it's completely trapped. It only exists in your current session. The moment you close that laptop or shut down that script, poof, all that training, all that intelligence, it's just gone.
And that's what we're going to call our first big idea here, the smart but trapped model. And trust me, this is a hurdle that every single data scientist and machine learning engineer has to clear.
Think about what a model really is in your code. It's just an object living in your computer's temporary memory. It's RAM. So if you want to reuse it, share it with your team, or, actually deploy it in an application, you need a way to make it permanent.
So how do we break it out of that temporary prison? Well, that escape plan has a name: serialization. This is the key that unlocks everything. So what exactly is serialization? It sounds complicated, but it's really not. It's just the process of taking your live trained model and converting it into a file. That's it. But inside that file is all the magic: the learned weights, the architecture, the intelligence. This means you can load it back up anytime, anywhere, and it's ready to make predictions instantly. No retraining needed.
And the workflow is beautifully simple, right? You train your model, same as always. Then you serialize it, which just means saving it to a file. Later, maybe minutes, maybe months, in a completely different application, you load that file back up. And just like that, you're making predictions. That's the whole game. Okay, so the process is straightforward, but it brings up a super important question. What kind of file are we saving it as? As it turns out, choosing the right format is a really big deal. Now, if you're in the Python universe, you've got two classic options. There's Pickle. It's built right in, it's easy, and it works for all kinds of Python objects. But for machine learning, especially with libraries like scikit-learn that are full of big NumPy arrays, Joblib is often a much better choice. It's specifically built to handle those large numerical structures, which makes it faster and way more efficient. But what happens when things get more complex? Let's say you've built this cutting-edge deep learning model using PyTorch on a big, powerful server. But the production app where it needs to run is written in C++ on a totally different operating system. A Pickle or Joblib file, which are Python-specific, are useless here. It feels like you've hit a wall. And this isn't some rare edge case. This is a huge challenge in the real world. So how do you possibly bridge that gap between different programming languages and frameworks? Well, the answer is this fantastic format called ONNX. It stands for Open Neural Network Exchange. And the best way to think of it is as a universal translator for machine learning models. You can train in one framework, export to ONNX, and then load and run it in a whole bunch of other environments. It's the real key to portability. And of course, we can't leave out the TensorFlow folks. Their ecosystem has the SavedModel format. And this thing is a beast. It's designed from the ground up for huge production-scale deployments, and it works seamlessly with all the big cloud platforms. So let's quickly break it down. For simple stuff, all within Python, Joblib is your best bet. If you live and breathe TensorFlow, SavedModel is your go-to. But if you need to cross any kind of boundary, from one framework to another, one language to another, ONNX is the absolute winner. Okay, that's enough of a theory. Let's take a look at how these serialized models actually work out in the wild, powering real applications that we use every day. So here's a look at a really simple web API. Just look at that one single line of code. That's the magic right there. With that one command, we are loading our entire pre-trained model into memory, ready to serve predictions. We're not doing any training here. We're just loading up all that saved intelligence. And this is exactly why serialization is the backbone of MLOps. That model file is completely portable. You can just copy it over to a server. The API can load it in an instant and start making real-time predictions. It just works, every single time. And this isn't just for little side projects. This is how major industries run. Banks are using serialized models for credit scoring. Hospitals deploy diagnostic models using ONNX on all kinds of medical devices. And yeah, every time you see a product recommendation online, you can bet you're interacting with a serialized model.
Okay, so you're probably getting ready to start serializing your own models. Before you jump in, let's cover a few pro tips to make sure you're doing it the right way, the production-ready way. First, and this is huge, always version your models. Just like your code, your models will evolve, and you need to track those changes. Second, be smart about security. A format like Pickle can actually be dangerous, so you should never, ever load a Pickle file from a source you don't trust. And finally, automate everything. Use tools like model registries and cloud storage to manage your models like a pro. Think of this as your little cheat sheet. Worried about models working across different frameworks? The solution is ONNX. Afraid that different library versions on your server will break your model? The solution is Docker. Concerned about security and organization? The solution is a model registry. For every common problem, there's a well-established, effective solution. If you take away just one thing today, let it be this. All that hard work you put into training, that's what makes a model smart. But it's the simple act of serialization that actually makes it useful. So, the main takeaway here is that serialization is so much more than a technical step. It's the essential bridge that connects your research and training to the real world. It's what makes your hard work reusable, scalable, and ready to make a real impact. Thanks for tuning in.